Hey Lexi. So I think this is kind of similar to the drawing that was in here. If I move that down, you can kind of imagine like there's A, B, C, D, and then here's angle B, angle C, angle D, angle A, and those would correspond. Like here's angle A, B, C, and D. So part A is basically asking which of these statements here would be true if we were looking at this picture right here. So I just kind of made this because it'll be easier for us to do those transformations. So for the first one, it's saying that C plus B, so the angle C, which is this one right here, this angle right here, and angle D, or sorry, angle B, which is this angle right here. So it's saying that these two angles are equal to this angle over here and this angle right here. Sorry, this angle, these two angles right here, C plus B, is equal to C plus D. So if you look at these two angles together, these two angles are a linear pair, meaning that they make up a 180-degree angle together. And these two angles over here, this angle and this angle, are also a linear pair, which means that they are also supplementary. They add up to 180 degrees. So A would actually be a correct choice for this one. If you look at the next one says D and B are equal to each other. So this angle, or not equal to each other, but they add up to 180 degrees. Only linear pairs add up to 180 degrees, which means angles that are supplementary. These two angles here are not supplementary. They are both acute angles, and two acute angles cannot be supplementary. So B is false. C is a little bit confusing. C says you're rotating clockwise by angle ABC using center B. So basically what you're doing is you're taking this whole figure and you're rotating at the same number of degrees that are in angle C right here. And then what it's saying is that angle CBD, so this angle right here, would be the image of angle ABE. So basically it's saying if we rotate it this many degrees, then these two will basically switch places. So I don't know if I can do it very well on here, but we're going to try. So if I construct this angle here, and this is just in mind, but this would work for any one of them. If we have a 133 degree angle here, and we want to rotate this whole thing, we're going to rotate it around B, and we're going to go negative because it's said to go clockwise, and typically when we go clockwise that's a negative angle and counterclockwise is a positive angle. So if we rotate this right here negative 133 degrees, and then we rotate this one negative 133 degrees, you can see that's not actually going to land right on top of each other, and so that would not be a true statement. This might be a little bit easier if I do apply here. So now you can see, like, when I rotate this figure here to 133 degrees, this one's going to land over here, but this line right here would land like this. So that one actually does not take this angle here to this angle here. That's not going to be a correct statement. If we rotate 180 degrees using center B, then it says CBD is the image of angle EBA. So if we were to take this and define our transformation as a rotation 180 degrees, and remember 180 degrees, it doesn't matter whether you go clockwise or counterclockwise. So I'm just going to type in 180 degrees here, and then I'm going to rotate this line 180 degrees, and I'm also going to rotate this line 180 degrees. And you can see that it doesn't look like anything really changed. but you can see that the lines get a little bit lighter if I redo those. So basically what that's telling us is that when I rotated this 180 degrees, it went onto itself. And when I rotated this one, it went onto itself. And so then that just means that these 2 points really switched places and these 2 points switched places. So all of the angles are reversed. And so that means that E would be a correct statement. I'm sorry, D would be a correct statement. If we reflect across the angle bisector of ABC, this one you might be able to see fairly well. The angle bisector is where, I'm just going to draw it here really quick. The angle bisector would be halfway in between this angle right here. I'm going to use a line. And then I'm going to hide these 2 little figures, these circles here that I've drawn, so that they're not really in our way. And we're going to use that to reflect over. So you can kind of see already, if we take this angle and we reflect it over this line, it would be sitting exactly on top of this angle right here. So reflecting across that angle bisector would actually cause these 2 angles to sit right on top of each other. So E would be a true statement. But then if we reflect across line CE, remember that when you do a reflection, you're basically doing perpendicular bisectors. And so if we were to reflect A across line CE, and this is one of the reflections that we did today in class, point A prime would be down here. And so reflecting across this line right here is not going to take point A to point D, which is basically what this is saying. Okay, point D is going to go to A, point B is going to go to itself, which will happen, but then point C is going to go to point E. And if we reflect C across that line, remember that C would be on the line of reflection. And when you when a point is on the line of reflection, it does not move. So it's not going to take C to E. I hope that helps. If you have any other questions, please let me know. I'm glad that you were working on this. We'll also go over some more things in class on, let's see, you would be Tuesday. So hopefully those will also help clear up any questions that you have. Have a good night.